All right, so we're going to start, obviously, like we do every day, reviewing what we did yesterday, which I'm hoping should be pretty fresh in our minds if we're doing this on a daily basis. And then we're going to start solving very basic quadratics using completing the square, using square roots. And again, right, this is all kind of stuff I would generally do in one day, but remotely it doesn't always come across kind of the same way. So we're really going to kind of stretch it out and do this slowly. So I'm hoping that that really helps us with the understanding. So yesterday we said if you want to make a perfect square trinomial, you take the coefficient of x and you divide it by 2, and you square the results, and that will give us the value of c that makes this a perfect square. So again, and I won't do this for all of them, but if we want to check it, x squared plus 10x plus 25 is a perfect square, because if we were to factor it as the product of two binomials, it would be the quantity x plus 5 times itself. And let's do the same thing for the second one, right? If I take negative 16 and divide it by 2, I get negative 8. And negative 8 squared should give us positive 64. So c is 64. And we said we can do it for the odd ones too, except it just ends up giving us a fraction. So negative 3 divided by 2 is negative 3/2. Squared is 9/4. So that's not so terrible, especially with the calculator. All right, so how would we solve this using square roots? Well, again, guys, this lesson should be pretty simple, because these are still kind of the building blocks to actually do the completing the square. So really what I'm going to do is I'm going to factor this. So assuming this is a perfect square, which I'm giving you all perfect squares today, it would look like this. And x plus 3 times itself can be rewritten as the quantity x plus 3 squared. Well, if I've got two equal quantities and one of them is a square, then I can take the square root of both sides. So the square root of x plus 3 squared is x plus 3, right? If you square something, squaring and taking the square root are inverse operations. So if you take the square root of a perfect square, as in, let's make it a very simple example, square root of x squared is x. So the square root of the quantity x plus 3 squared is just x plus 3. We lose the square root or we lose the radical. Now, this first one is very different because 0 only has one square root, right? Going forward, we're going to have to put plus minus. Now, we're not going to do that here because there's no, as some of us know, because we've had some jokes about this, there's no negative 0. And there's no positive 0 either. 0 doesn't have a sign. So with this one, we just have to solve the one equation, and we get x is negative 3. And if we were to go back and check from the beginning, right, we're going to get negative 3 squared is 9, minus 18 is negative 9, plus 9 is equal to 0. All right, so this is more, so we're taking the same expression, except instead of having it equal to 0, it's equal to 25. So when I factor it, right, we already looked at this. I don't need to show both steps here because I showed it with the last one. I showed this as my bridge step to get me the quantity x plus 3 squared. So now we said we're going to take the square root of both sides. So what's the square root of x plus 3 squared? It's x plus 3. What's the square root of 25? And this is really, really, really important. And if you miss this step, all your answers are going to be incomplete. You're going to have half your answers. It's plus or minus 5, right? The square root of 25 is 5 because 5 squared is 25. But negative 5 squared is also 25. Now, this is going to change the way we solve the rest of the equation because now we need to split it up. We need to say, well, one possible path is that x plus 3 is equal to positive 5, while a second possible path is that x plus 3 is equal to negative 5. So if x plus 3 is equal to 5, then x is equal to 2. But if x plus 3 is equal to negative 5, then x is equal to negative 8. So my solution set is that x can be negative 8 or 2. Now, we said from the beginning, guys, more often than not, quadratic equations have two roots. They have two solutions. The only ones that don't, aside from irrational and imaginary things like that, the only ones that don't are perfect square trinomials. And that's what we saw with the first one. Perfect square trinomial is equal to 0. This is a perfect square trinomial equal to 25. Now, what would we have done before today? Well, if I was doing this when I was in 8th grade, since I didn't know how to complete the square, I would have subtracted 25 on both sides. And it would have gave me x squared plus 6x minus 16. And I would have factored it as x plus 8 times x minus 2, which would have given me -8 and +2. So that's what I'm saying about this is not something that is absolutely necessary, but it is a standard, and it's something that next year you'll be expected to know from this year, the fact that assuming you complete the course. So going forward, and that's a way to check, right? If you're not sure, you're like this completing the square stuff, I'm not sure if I did it right, go back and do it the traditional way. And you'd be able to do what I've got here and then go back and factor it. All right, so let's stay the course and do the same thing here, right? So I've got x squared minus 8x plus 16. All right. Now I shouldn't have to do this part every single time, but let's take a look at it. X minus 4 times x minus 4, right? And again, our rules are the same. We're looking for two numbers that multiply to 16 and add up to -8. All right. So we've got x minus 4, the quantity squared, is equal to 49. Now I take the square root of both sides. And again, we need to really understand, right? This here is of utmost importance, that plus minus there. If you don't have plus minus, you're only going to get the positive root. And some of us, I'm not sure why we were doing this, but when we were doing some other equations that I had done maybe 2 weeks ago, difference of two squares type things, probably because we were using photomath, you move the term, x squared minus 49 equals 0, let's say, you would move the term, take the square root, and only take the positive root. So let's be very careful here, right? So I'm going to split this up. And again, one case is that x minus 5 is equal to 7. And the other case is, x minus 4 is equal to 7. And the other case is that it's equal to -7. So one solution is that x is equal to +11. And one solution is that x is equal to -3. So my solution set, if I want to write it as a solution set in braces, which we should, is -3 and +11. And if we want to just quickly go back and check, if I sub in -3, I get 9 plus 24 is 33 plus 16 is 49. And if I sub in 11, I get 121 minus 88 is 23. 33 plus 16 is 49. So that will check. All right, so this we'll call like a supplemental one, okay? So I don't want to confuse too many of you guys. So if you're having trouble with this, I want you to take a look at it, go through it. But I don't want you to get too hung up on the ones with the coefficient of x squared. That's not one. All right, so again, this is not something we'll typically see in Algebra 1, but you'll see it next year. So we might as well, go over it. And it's in our textbook and our workbook. So we need to figure out how I can factor this. So it really shouldn't be a surprise, right? We did factor these. When we did factoring, we did a day of factoring perfect square trinomials and difference of squares, and this is a perfect square. So I know 2x times 2x is 4x squared. I know 7 times 7 is 49. I know the middle sign is negative. That really shouldn't have been terribly difficult. So now I've got 2x minus 7, that quantity squared is equal to 100. Now we take the square root of both sides. So now I get 2x minus 7 is equal to plus or minus 10. And again, that plus or minus is very, very important that we've got that plus or minus there. So now I've got these two cases, right? I've got case 1, which is that 2x minus 7 is equal to 10. And I've got case 2, which is 2x minus 7 equals -10. And I'm going to solve both of those equations, and they will both give me fractions. So if 2x is equal to 17, then x is equal to 17 halves, which if you want to say 8 1/2, that's fine, or 8 5/10. And I've got 2x minus 7 equals -10, 2x equals -3, so x equals -3 halves. So those are my two solutions, 17 halves and -3 halves. Again, the algorithm or the approach is really the same. All right, so here's our now try. So again, guys, I'm really encouraging you guys to do this as practice. I'm not giving you so many for homework, so it's good to see some here and then some homework questions that are a little bit different. If you're just doing the 3 or 4 or 5 or whatever it is for homework, you're really not getting the full practice, especially if you're not doing the examples as I'm doing them. So this is where we pause it, right? And then we come back after we're done. I'm going to do one at a time and kind of wipe them out. So for the first one, it should be the quantity x plus 4 squared equals 25. Right, which gives me x plus 4 equals plus or minus 5. Now we'll split. I get x plus 4 equals 5. I get x plus 4 equals negative 5. So one of my solutions is x is equal to 1. And one of my solutions is x is equal to negative 9. All right, for the next one, and again, guys, if I went too fast, we can pause and go back. That's why I'm not doing it on separate slides. For the next one, it's going to be the quantity x minus 5 squared. So now we take the square root of both sides. I get x minus 5 equals plus minus 4. So now we split it up. X minus 5 can be positive 4, and it can also be negative 4. So one solution is that x is 9, and one solution is that x is 1. All right, the third one I can probably just do down here, right? So I've got the quantity x minus 7 squared equals 0. So I get x minus 7 equals, we don't have to do plus or minus 0. And then just get x is 7. That should be a very simple one. And then let's take a look. I'll take this down and we'll look at the last one. So again, right, factoring this is something we actually did in class. I know it was a while back, but we did it. So to get 9x squared, I'm going to do 3x times 3x. To get 4, I'm going to do 2 times 2. And I'm going to take the sign in the middle. So if I do the FOIL there, 3x plus 2 times 3x plus 2, I get 9x squared plus 6x plus 6x, which is 12x plus 4. So I get the quantity 3x plus 2 squared is equal to 100. I'm going to take the square root of both sides, right, which is going to give me 3x plus 2 equals plus or minus 10. So I get 3x plus 2 equals 10. I get 3x plus 2 equals negative 10. So I get 3x equals 8. So one of my roots is x equals 8/3. And I get 3x is equal to negative 12. So one of my roots is going to be negative 4. All right, and as always, guys, whatever questions you have about this lesson, make sure you ask me, because tomorrow and the next day it's going to progressively get a little bit more challenging. So make sure whatever questions you have that you ask. And I would also say try to keep up with it. I know I give you 2 days for the work. Try to keep up with it each day. Right? If you let a couple days go by and then you're trying to catch up with 2 homework assignments, it's going to be a lot. The videos are getting longer because the work's getting a little bit more challenging. So just try to keep up with it day by day so we don't get too far behind.